Dear students, in the previous video I have discussed about the body fluid and circulation. In that chapter I have discussed about the plasma, the composition of plasma, the various type of blood corpuscles present in the plasma, and a brief discussion about lymph. In today's video I am going to discuss about blood groups and the formation of clot. So let's start with the blood group. Now what is blood group? The plasma membrane of the RBC contains certain glycoproteinaceous molecules. These glycoproteins are called antigens. These differ in different persons. Depending upon the nature of the antigens, two important common type of blood grouping are found in human beings. They are the ABO blood grouping and the RH blood grouping. So first let's discuss about ABO blood grouping. Now in ABO blood grouping, this type of blood grouping was reported by Carl Landsteiner. It is based on the presence or absence of antigen A or antigen B on the surface of RBC. People with blood group A have antigen A on the surface of their RBC and they have antibodies against antigen B in their plasma. While in the people, those who are having blood group B, in that cases, it is just vice versa of the blood group A. Apart from both these blood groups, that is A and B, people with blood groups AB have both the antigens A and B on their RBC surface and no antibodies for either of the antigens in their plasma. Now, ABO blood groups were discovered by Landsteiner in 1900s. What's about blood group O? Before discussing about blood group O, let's discuss about the AB blood group. Now, A, B and O, as I told you, these blood groups were discovered by Landsteiner in 1900. So, blood group AB was discovered by D. Castello and Steney in 1902. Now, in people with blood group O, both the antigens A and B are not present on their RBC, but they have antibodies against this in the plasma. This distribution of antigens and antibodies in the four blood groups are blood group A, blood group B, blood group AB and blood group O. Well, so blood group A, which has the antigen on the RBC surface, has antibody anti-B in the plasma, and the donors group are the A and O. While blood group B, the antigens are present on the surface of the RBC is B, and the antibodies in the plasma is anti-A, and the donors group is B and O. While blood group AB, the antigens on the RBC is A as well as B, while there is no antibodies or antibodies on the plasma, and the donors group are AB, A, B as well as O. And finally, blood group O, the antigens on the RBC is nil, there is no antigen, while there are anti-A and anti-B antibodies in the plasma, and the donors group is O. Next, discuss about RH grouping. Apart from these antigens discussed in the previous section just now, another type of antigen is there known as RH antigen, which is similar to the one present in the rhesus monkey. This type of antigen is found in the RBC surface in majority of the human beings, nearly 80%, and the individuals having this RH antigen are called RH positive people, while those without this RH antigen are known as RH negative people. RH group is mandatory to be matched before transfusion of blood is done. An RH negative person, if gets exposed to RH positive blood group, it will form specific antibodies against the RH antigen. Here, one very important technical term that you have to remember is RH incompatibility during pregnancy. A special case of mismatching of RH group or Rh incompatibility have been observed between the Rh negative blood of the pregnant mother with the Rh positive blood of the fetus. The fetus of Rh negative woman and a Rh positive man. In such a case, the mothers become sensitive while carrying a Rh positive baby in her womb. The reason is that some of the RBCs from the developing fetus enter into the bloodstream of the mother during the development. In those cases, the development of the anti-Rh antibodies in the mother's blood take place. The Rh antigens of the fetus do not get exposed to the Rh negative blood of the mother in the case of first pregnancy because the two bloods remain separated by placenta. However, during the delivery of the first child, there occurs a possibility that the maternal blood may get exposed to small amount of Rh positive blood from the fetus, hence preparing the antibody against the Rh antigen in her blood. Thus, in case of her subsequent pregnancies, Rh positive fetus gets exposed to the Rh antigen, anti-Rh antibodies, and these antibodies will reach the blood of the fetus, the Rh positive, and destroy the fetal RBC. This could be fatal to the developing fetus and can cause severe anemia and jaundice to the developing baby. So, this is known as erythroblastosis fetalis or hemolytic disease of the newborn. What is the precaution for this problem? This condition can be avoided by administering anti-Rh antibodies to the mother immediately after the delivery of the first child. Rh factor was discovered by Landsteiner and Wiener in 1940 after immunizing the rabbits with the blood of a monkey. There are various type of, say, 30 or so on known antigens on the surface of the RBC, and that can give rise to different blood grouping. For example, there is another type of blood grouping called Mn blood grouping, etc. The next very important topic is the coagulation of blood or clotting of blood. You have already seen from your childhood that when an injury is caused, the wound normally does not continue to bleed for a long time and the blood stops flowing after some time. It is a natural property exhibited by the blood to check the excessive loss of the blood from an injury or trauma. Now, clotting of blood is a complex process that involves various enzymatically controlled steps for its completion. Now, what is the formation of a clot? An injury or trauma causes stimulation of platelet cells to release the certain platelet factors. This in turn activates the mechanism of coagulation or the clotting of blood at the site of injury. Coagulation or clotting of blood. Now, when an injury or a trauma takes place in our body parts, there causes a stimulation of the platelet cells to release certain platelet factors. These platelet factors in turn activates the mechanism of coagulation. Now, there are three main steps that mainly act as the formation of coagulation or coagulum. So, what are the three steps? Let's discuss. The first is the thromboplastin formation. The thromboplastin, it helps in the formation of an enzyme thrombokinase, which inactivates the heparin that converts into inactive plasma protein, that is prothrombin, into its active form called thrombin. The thrombin thus acts as a proteolytic enzyme to convert fibrinogen molecule that is produced in the liver in the presence of vitamin K to form insoluble fibrin monomer. And this reaction required thrombokinase and enzyme complex, which is formed by the series of linked enzymatic reactions, which involves a number of various factors present in the plasma in its inactive state. Both the changes mentioned above require calcium ions for their reactions. The third step is these fibrin monomers polymerize to long sticky fibers. The fibrin thread forms a fine network of thread called fibrins, in which dead and damaged formed elements of the bloods are trapped. This finally led to the formation of clot or coagulum. which is a dark reddish brown scum formed over the surface of injury. So, dear students, this was all about the mechanism of blood coagulation and the various type of blood groups. In the next video, I will discuss about the working of the heart, and you will study there about double circulation in human heart. Thanks for watching the video. Take care. Bye.